Theorem about field axioms. Theorem about field axioms. Theorem for each real number x, negative of minus x is x. Here you watch here. Negative of minus x is x. Negative of x plus y equal to negative of x plus negative of y. Proof for first subdivision. If negative of minus x be denoted by z, z is negative of minus x. So when we add these two factors minus x and z become 0, we write the result x equal to x plus 0 from the property of 0. So it become x plus, we write the minus x plus z for 0. Since minus x plus z equal to 0, so we apply the result for 0. We apply the associative law for addition. Associative law for addition in R. So x plus minus x plus z. This becomes 0. So this is z. Z is nothing but negative of minus x. There you have negative of minus x. Hence the first proof. Second, negative of x plus y equal to 0 plus 0 plus negative of x plus y. Just we add two zeros with the term negative of x plus y. X plus minus x for 0. We write x plus minus x for 0 and y plus minus y for another 0. Minus of x plus y remain unchanged. We apply the associative law of addition. It become these two terms become 0. So negative of x plus negative of y. The next theorem. The x and y be real numbers such that x y equal to 0, then either x equal to 0 or y equal to 0. Whenever we multiply together two elements, the result is 0. Either one of the element must be 0. We confirmly saying that any one of the element must be 0. We approach this result by two ways. First, if x equal to 0, there is nothing to prove. Suppose if it is not x is not equal to 0, if we approach the theorem, if x equal to 0, we have finish. Finish means nothing to prove. If x not equal to 0, for any non-zero element in the fields, immediately it exists inverse. So x inverse inverse, x inverse exists. By the law of existence of inverse of multiplication, x inverse exists. Now we consider x y equal to 0 from the theorem. We write the result, this equality from the simple theorem x dot 0 equal to 0. This is multiplication between x and 0. So we simply replace x by x inverse here, x by x inverse and 0 by xy. We write the xy for 0 here because of xy equal to 0. So from this result we write this one. Now apply the associative law of multiplication. So x inverse x become 1. This is y. So y equal to 0. Whenever x not equal to 0, y equal to 0, we multiply both element x and y. The result is 0. We can confirmly saying that any one of the element must be 0. Next, cancellation of multiplication. If x, y, z be real numbers such that x, z equal to y, z and z not equal to 0, then x equal to y. We taking the equality x plus minus y of z equal to x z plus minus y z. Taking the inequality with the property of distributivity of multiplication over addition here. We apply the property that's. So we replace xz by yz here. Replace uh, xz by yz. Uh, we apply the associative law, the distributivity of multiplication over addition here. Distributivity of multiplication over addition. So this becomes 0, 0 is so which is 0. You just watch here x plus of minus y into z equal to 0. This result becomes 0, but already we take z not equal to 0. So x plus of minus y is 0. X plus of minus y is 0. We write 0 by y plus minus y. Y plus minus y. Now we apply the right cancellation law of addition. So x equal to y. So hence the result. Cancellation of multiplication. Yeah. Next. Next theorem. For all x, y naught, negative of xy is x of minus y. Negative of xy is also minus xy. The negative here, the negative of x is negative of y equal to xy. Proof. The result is equivalent to saying that x of minus y is the negative of xy here. X of minus y is negative of xy. When we add these two factors become 0, we must therefore show that the sum of xy and x of minus y is 0. So we add these two terms x minus y plus xy equal to x into minus y plus y. We apply the distributivity of multiplication over addition law. This become x, this becomes 0. So it is 0. The sum of the two factor is 0 means that uh, these are negative each other. Uh, Negative each other. This means that the negative of x of minus y is xy. Negative of x y is x of minus y, or the negative of x of minus y is xy. Next, minus x y equal to y of minus x. We write minus x y equal to y of minus x by using the law of commutative law of multiplication. Here we apply the first results. Y of minus x equal to minus of xy. Here y of minus x equal to minus of yx. Here you watch here x of minus y equal to minus of xy. So y of minus x equal to minus of yx. It's become again we use the commutative property of multiplication. So yx become xy. So we prove the second result. Next, minus x minus y equal to minus of minus xy. Here again we use the first property. Suppose if it is not negative x of minus y, this become minus of xy. Here we write minus x minus y. So minus of minus xy, again we apply the same property here. Minus of xy equal to xy, minus of xy here. This become xy, and this prove the result. was here. Next, two important definition: subtraction and division. These definitions are defined from the basic definition multiplication and division. The difference between two real numbers x and y is given by x plus of minus y and is denoted by x minus y. Here we write the subtraction in terms of addition. The operation of finding the difference is called the subtraction. Another definition: the quotient of real number x by y, y not equal to 0. This is important. Subject means the condition is given by x y inverse and is denoted by x y, x slash y, or x divided by y. So these are basic definitions. Here we do the third property of the theorem. Here, what's here? Apply all the properties. Just write the properties means reason against each and every step. These steps must be right in your examinations, and you must be understood how to write the